The starter solution for this module is slightly different from what we ended up with in the last module. The first thing we'll do in this module is trade in the in-memory user store for our custom user store. For the demo, I wanted to avoid you having to install SQL Express or full SQL Server instance. So the repository stores the users in JSON files through a context instance. However, exactly the same can of course be achieved with a database instead of with JSON files. Let's have a look at the structure of this. What we see here is that the user has very few fields in the user class. Subject, username, password is active, and that's about it. By the way, in a real-life situation, you'll want to ensure your passwords are encrypted in a way that cannot be decrypted anymore. He does have a list of claims. That's where given name, family name, and other claims end up in. A user claim class consists of subject, claim type, and claim value, and an ID. A user also has a list of user login. These will be used to link a user's account to the external identity providers he might have. For example, his Facebook account. We'll encounter these later on. Now, how do we ensure this user store is used instead of the in-memory users? We do that through a custom user service, overriding the user service base class. Let's add one in a services directory. A custom user service provides semantics for users to authenticate with local accounts as well as external accounts. It also provides identity and claims to identity server needed for tokens and the user info endpoint. Additionally, the user service can control the workflow a user will experience at login time before being allowed to return to the client application. This is useful for things such as additional login requirements, such as two-factor authentication, or other custom requirements, such as accepting an end-user license agreement. In short, if we want to customize anything having to do with authentication, we'll want to use a custom user service. So we'll encounter this a lot in this module. Let's have a look at that base class. The user service base class allows us to override methods that require a custom implementation depending on our use case. The first one we see is the authenticate external async method. This is called when the user uses an external identity provider to authenticate. It allows the user service to map an external user to a local user. The next one is authenticate local async. That one's called for local authentication, i.e. whenever the user uses the username and password dialog. It's in this method that we can check whether or not the passed-in username and password exist and match. Then there's the getProfileData async method, called whenever claims about the user are requested, for example during token creation or via the user info endpoint. So it's here we have to get the claims for the user. Then there's isActiveAsync. This method is called whenever identity server needs to determine if the user is still considered valid or active. For example, if the user's account has been deactivated since they logged in. 3 more. Post-authenticate async is called after the user has successfully authenticated, but before they are returned to the client application. It allows a consolidated place to check for custom user workflows after all of the other authentication methods. Pre-authenticate async is called before the login page is shown. This allows the user service to determine if the user is already authenticated by some out-of-band mechanism, like client certificates, and it can prevent the login page from being shown. And lastly, there's sign-out async, which is called whenever the user signs out. We'll encounter these throughout the module. Let's start with authenticate local async. We're switching out our current in-memory user store for a custom one that's still local login using username password fields. In this method, we'll have to provide our custom authentication logic. We're authenticating against our custom user store. The repository exposes a getUser method that will return a user if the inputted username and password match. Next, we'll want to set the authenticate result on the context. That is the return value of all the authentication methods in this user service. The return authenticate result indicates one of many possible outcomes. The outcome depends on the constructor we use. When we input a subject and a name, and possibly other parameters like claims, we state the result is a full login, used to log into identity server. When we only pass a string, we indicate that something went wrong. The string passed in is the error message. The other 3 overloads are used for partial logins. We'll encounter that principle later on in this module. Then we'll need to override the method used to get profile data. GetSubjectID requires using identityserver3.core.extensions. This is where we'll need to set requested claims. First, we'll find the current user from our repository. We always have to add the subject as a claim. We also have to return other claims, but not all claims a user has. We only want to return those claims that are linked to the scopes requested by the client when asking for a token. For example, when the profile scope is demanded, we'll want to return profile-related claims like given name and family name. Context.requestedClaimTypes contains a list of requested claim types, so we return that subset. To return those, we set the issued claims property on the context. Lastly, the isActiveAsync method. We use this method to check if a user is still active. A user's account might be inactive until he confirms he's indeed who he says he is by clicking a confirm registration link in the mail. Or you might have a use case where the user becomes inactive after not having paid his subscription. This is where we can check for that. Lastly, we need to ensure Identity Server uses our custom user service. We do that in the startup class. We create an instance of the custom user service, and we set the user service property to a registration of iUserService. The user service base class implements iUserService. And we no longer need to use our in-memory users now. And that should be it. Let me set a few breakpoints on these overridden methods so we can check out the flow. The first breakpoint is hit, authenticate local async, for checking if the inputted username and password match. Then we hit isActiveAsync to check if our user is still active. After that, we enter getProfileDataAsync. The first time we hit this, only the role is requested, used to create a user at Identity Server level, i.e. the user that logs into Identity Server. Then we continue, and we hit the getProfileDataAsync method again. This time it's our real request. The requested claim types here match the claims requested by the MVC application through the scopes. And we're logged into our application as Kevin. With that, our users are now in a custom user store. And that begs the question, what if a user isn't in our user store? We must provide a way for the user to register. That's what we'll cover in the next demo.